Now we are going to do March 22, paper 42, mechanics 1. Okay. Now, look at the first question. You are given a crane which is lifting a load of 600 kilogram. So 600 times G, which is acceleration due to gravity. This is the downward force. There is it is moving upward with a constant speed through a height of 15 meters. Okay, from the ground to here. Now, the work done by the driving force, total work done by the crane only. Okay, it will include the gravitational potential energy gained by the block, and then the work done against friction in the bearing. Now, if you add the energy, gravitational potential energy gain, okay, plus the work done against friction, this will be the total work done by the driving force of the engine. Now, gravitational potential energy is mass times acceleration due to gravity, 10, times distance in meter, plus the work done given here. So very easy question. Now the second part, given that the average power of the exerted crane is 12.5 kilowatt, find the total time for which the block is in motion. Now you are told to find the total time taken. Now you know that power is a work done upon time. So power is given 12.5 kilowatt. So you convert into watt. Then work done, if you are given the work done here, over time, you just replace and you will get 8 seconds. So easy. Okay. Now let's do number 2. Number 2, a particle piece projected vertically upward from the ground with initial speed u. P reaches a maximum height of 20 meters above the ground. Now, what is being given? The initial speed, which is u, s, the displacement from the ground, 20 meters. Acceleration is moving upward, so the acceleration is minus 10 meters per second square. V is 0 because when it reaches maximum height, V is 0, final speed is 0. So you are told to find u, the initial velocity. Now you are given u, v, u, a, and s. So we use this equation. We replace all the values. Okay. Then we are going to get u. Now u cannot be negative, so it is 20 meters per second. Okay. Now the second part of the question, I find the total time at which P at least 15 meters above the ground. So we know that the maximum height reach is 20 meters. So 20 meters. So you are told 15 meters, about 15 meters. Now we know that when a body is projected upward, it will return here. Not on the same position, but here. Now 15 meters here. If we find the time it reaches this distance, and then the time it is upward above 15, so this is the time taken. A total time P is at least 15 meters above the ground. We have to find the time it stays here. So how to do this? A time taken to reach 15 meters above the ground, you are given the initial speed from above. Okay. Now, if you have done a mistake here, this also will be wrong. Now, you have given u, you have given s, which is 15 meters. Okay. The displacement, acceleration is moving against gravity, so it is negative. Now you have to find the time taken. How to do this? You have displacement, you have u, you have t, you just have to use this equation. Now we replace all the values, we get a quadratic, you solve it, then you will get t is equal to 1, t is equal to 3. Now, therefore, if you got two values, 1 and 3, this means that at t is equal to 1, it is 15 meters above the ground, and at time 3 seconds, it is again 15 meters above the ground. Okay, this is displacement. So, you take this time interval, you minus this time interval, you get the time taken. The total time p is at least 15 meters above the ground. During 2 seconds, it is 15 meters above the ground. Take this value minus this value, you will get this. Okay, now we do number 3. Number 3, you have a car of mass m kilogram is towing a trailer of 300 kilogram down a downhill incline 3 degrees to the horizontal constant speed. Now, if a body is moving down slope, so there is loss of gravitational potential energy and kinetic energy is involved here. So a constant speed means no change in kinetic energy. Okay, no change in kinetic energy, therefore the kinetic energy is uniform. Now a car M, you are given the mass of the car that you have to find. The mass of the trailer is given, the inclined plane 3 degrees. There are resistive force on the car. Okay, work done against resistive force in a distance of 50 meters only is 40,000. So this is the distance 50, and the work done in this to move this 50 meter, it is 40,000 joule. In the engine of the car is doing no work done. No work done. The tow bar is light and rigid. So if there is no work done by the engine, therefore if it is moving down, this is because of gravity, which is causing it to move down. So if the engine is doing no work, so no driving force by the engine. So source of energy is a decrease in gravitational potential energy. Okay, so let us find the gravitational potential energy. Gravitational potential energy is m times 300 times 10. Okay, times 10. M is the mass of the car plus the mass of the trolley times g, which is acceleration due to gravity, mgh. H is height, so this height here, you have this angle, you have hypotenuse, then you can have height 50 sine 3 degree. Okay, you get, and this is equivalent to the work done against resistance. This is equal to a work done against resistance. Why it is equal to work done against resistance? Because you are told that it is moving with constant speed. Constant speed means the energy it is moving down is equal to the work done against resistance, which opposes it. So we equate the two. When we equate the two, you will get mass. Okay? The very important point here is you have to know that why we equate these two. We equate these two because of constant speed. Okay? Now, look at here. The resistance force on the trolley only, on the trailer is 200 Newton. Find the tension in the tow bar between the car and the trailer. Tow bar is the bar that holds the trolley with the car, the trailer with the car. Okay, so this is the tow bar, the tension in the tow bar. Now, you are told that there is a resistive force on the trailer. Let's do it like that. So The resistive force is 200 Newton. As I told you, gravity is pulling it down because the engine is not on, using no work. So you have W sine theta. Now you have to equate both. You have the tension, which is moving down because the car is here. Tension plus W sine theta. You will get 200 there. Now T, you take the 200, you minus W is the weight of the trailer. The weight of the trailer is 300 kilogram times 10 sine 3 degree. And you equate, you will get 43 Newton. Therefore, there is a tension of 43 Newton in the turbo, which is found between the trailer and the car. What is important point we have here? You should know that we consider only the trailer here. We don't consider the car and the tension here. So 200 Newton is moving up. There is a resistive force of 200 Newton always moving against motion. Now, what forces move down? It is the weight sine theta of the trailer plus the tension. Okay, so this is how you get the answer. If you don't put the tension here, it will be a mistake. So this is important to put the tension plus the weight which is the component of the weight which is moving down. Okay, now we are going to do number 4. Now number 4, a total mass of a cyclist, so 70 kilogram. The cyclist is riding constant power, okay, up inclined plane, angle alpha, sine alpha 0.05. Now at an instance when the cyclist is 6 meters per second, the acceleration is this. There is a constant resistance of F Newton. Now, what to do? You're told that there is power. You're given the power. The power, when you're given power and you're given speed, you can find driving force. Driving power is equal to Fv. You should know this. And driving force is equal to power upon velocity. This is very important to know. Now, there is a constant power, inclined plane, important to know, constant resistance, things like that. Now, let us find all the forces that are acting on the cyclist. Driving force, and in the opposite it is the frictional force and the component of the weight. Now, driving force minus W sine alpha plus frictional force is equal to ME. When you remove the minus sign, you can add that. Is equal to ME. Now, W is the weight, so we have the weight of the cyclist and her bicycle, the mass of the cyclist and the bicycle. So you multiply by acceleration to gravity. Sine alpha you are given, it is 0.05. So you multiply it, and minus frictional force is equal to ME, mass times acceleration to gravity. No, acceleration of the bicycle, negative 0.2 ME. Now you substitute, you will have your force needed. Therefore, the driving force of the cyclist move up, and the component of the weight and frictional force move down. Now, very important, if one among you have not included W times sine alpha, you're just equating driving force and frictional force, it will be wrong. Okay, it will be wrong, because how you know that there is other force than frictional force moving down? Because you are given sine alpha, so you should use it. Okay, so immediately you should know that there is the component of weight which is also acting down. This is what you have to think. Now, remember, report a steady speed. Now, when you are told maximum velocity is reached or steady speed, the acceleration is 0. Okay, acceleration is 0, steady speed. This is very important. If you don't know that at the steady speed, acceleration is 0, then you won't be able to do this out. Now, the cyclist could maintain up the hill when working at his power. Now, find the steady speed. Now, you have the driving force. Now, the resultant force is 0 when the acceleration is 0. This is very important. Steady speed, acceleration is 0. When acceleration is 0, resultant force 0. Now, what resultant force we have? This minus this. Okay, now you replace driving force by 180 divided by V. Don't know the velocity. Now you replace W sine theta by W. You are given the kilogram, 70 kilogram times 10 mg sine theta, which you are given, plus frictional force you are given. You just substitute, you will get the value of V. Okay, now let's do number 5. Number 5, you are given 4 forces acting at a point, coplanar. So the magnitude of the forces are like that. You're told that the forces are in equilibrium. This is very important. Only when it is in equilibrium that we can resolve the forces. Now let us resolve it horizontally. You have to find F and G. You are given 2F, G, 10, and F here. So when resolve horizontally, this is resolved horizontally, you take F times cos 0, G times cos 60, 2F times cos 140. You always like that. Okay, now this, and the force here, cos 0, and G, it is G cos 60, 2F cos 140, 10 cos 270. Now is equal to 0, because in equilibrium, this is cos 0 is 1, so it is F. Cos G cos 60 is half, it is G capital. 2F cos 140, it is 0.766 negative. So 2F, then 10 cos 270, 270 is 0. So this is 0. You just substitute, simplify, you will get G is equal to 1.064 F. So this is your first equation. Now the second equation is resolve vertically. Now, you just replace sign in here. It is f cos 0, f sin 0, g cos 60, g sin 60. Just replace it like that. Now this is 0. Simplify. You will get this. Find the second equation. Now solve these two equations. You will have f like that. Then you will have f and g. That's simple maths. I won't do it in more detail. You have to use your brain. Okay? Now, what is important here? In equilibrium, you take all forces in that direction only. 0, 60, 140, and 270. You just put it here. When you resolve vertically, you just replace sign in the first one. Then you work out, you will get the answer. Now, for B, you're told that if F is free, find the value of G for which the resultant of the force is perpendicular to the 10 Newton. And now the 10 Newton is down. Perpendicular means here. If the resultant force is perpendicular to 10 is 10, so there is only the horizontal component. All vertical component is 0. There is no vertical component, there is only horizontal component. If resultant force is perpendicular to the 10, so the resultant force, there is only horizontal component. The vertical component is 0. So sum of all force, vertical force, is 0. Okay, so this is the vertical component. We resolve vertically. We replace in this equation here, we replace F by free. We replace F by free. 2 times free. We just substitute and you will have G. So this is the value of G for which the resultant force will be perpendicular to the 10 Newton. Okay, important point here. You should know that if the resultant force is 90, is perpendicular to the 10 Newton, for all force is the resultant force, there is only horizontal component. Therefore, the vertical component is 0. Now, what is the vertical component here for all the forces? These are the vertical component. You have to include this on this also. Now, in this equation, you replace F by free. Okay? Then you will get your answer. Good. Very good. Now, number 6, a cyclist starts from rest at a fixed point O and then move in a straight line. Therefore, it is point O, moving a straight line before coming to rest. K seconds later, K seconds come to rest. The acceleration of the cyclist at time t second after 0 is this. You're given acceleration in an equation for the acceleration. Very easy. As we know, the acceleration is rate of change of velocity, dv by dt. Now, if you change variable, therefore, when you integrate dv, you will get v. Therefore, if you integrate acceleration, you will get velocity. Now, this is what I have done here. You are told to find the value of k, the time when it stops here. So we have to find velocity. Now, how to find velocity? You integrate. When you integrate, you add 1. Then you would add 1 to this, become half. You divide by half. You add 1 to this, become 3 upon 2, divide by 3 upon 2. You simplify. Now, initially, when t is equal to 0, v is equal to 0. Why? Because you are told that it starts from rest. It starts from rest at point 0. This is why I replace v0. You know all these. When you replace t0, v0, you will get c0. So what is the velocity? It is this relationship. Now, coming to rest means v is equal to 0. K second later means v0. You put final velocity 0. When final velocity is 0, therefore you put all these 0. T power half common. T half is equal to 0. T is equal to 0. This is equal to 0. Therefore, t is equal to 2 times 5, 10 seconds. So, at t0 and t5, v0. Okay? Therefore, k is 10 seconds. Find the maximum speed of the cyclist. Maximum speed means acceleration 0. This you should know. This is the main point here. If you don't know that maximum speed, acceleration 0, useless. Maximum speed, therefore acceleration 0. So you take the relationship here, you put it 0. Then you solve for t. You will get t is equal to 10 upon 3. What does this mean? This means that at t is equal to 10 free, it will reach a maximum speed. So here at t is equal to 10 upon 3, it will reach a maximum speed. Then at k is equal to 10 seconds, it will stop. Okay. So what is the maximum speed? Maximum speed, the time. Find the maximum speed. Okay. So you have to find the time. You will get the time when it is maximum speed. Then you replace the t in the relationship of speed. Then you will get the Vmax cut point with set meter per second. Okay. Very important, this maximum speed means acceleration 0. If you don't know this, you can't proceed. Okay. Now there is a C out here. C out. Now here, find an expression for the displacement from 0 in terms of t. Right? Find an expression for the displacement of in terms of t. Hence, find the total distance traveled by the cyclist from the time she reaches maximum speed here at t is equal to 10 upon 3 seconds until she comes to rest. Find this distance. Now, how to find an expression for 0? Now, when you integrate velocity, you will get displacement because velocity is the rate of change of displacement. Okay, when you integrate velocity, you will get displacement because here, when you integrate acceleration, we get velocity. Here, where we get when we integrate speed, velocity, we get displacement. Now, we integrate this, you get this. Now we have to remove the c. Now when t is equal to 0, displacement is 0 because it is not moving. Now when you replace all these, you will get c0. So you get one relationship. This is the expression that is needed in the exam. Now you have to find the time, the distance between when from t is equal to 10 upon 3 to 10, t is equal to 10 seconds. What you have to do, you just replace this in your relationship. You will get the distance covered at t 10 upon 3. Then you replace t is equal to 10 in the same relationship. You will get that. This is the distance covered here. So you take this distance minus this distance, you will get the distance between maximum Vmax and until it stops. Very interesting question. Okay, what is most important here? If you don't know that, if you don't know this expression, you won't be able to follow to continue this question. You should know that displacement, the distance traveled, you have to integrate velocity to have displacement. Okay, right. Now we continue with number 7. Number 7, a bead. A bead is attached by a string on a rigid wire. Incline, angle, sine inverse, set low, and sank to the horizon. A is released from rest and moved down the wire. The coefficient of friction between A and the wire is mu. When A has traveled 0.4 meter, the speed is 0.6. Show that mu is equal to 0.25. Now, this is the wire. We don't know the height. We don't know the height. You know, when the bead A is moving a distance of 0.45 meter here, what is the height? What is the loss in potential energy? What is the height here? Now, if you draw a line here, because it has moved from here to here, this is the distance. Okay, this is the distance covered here. Now, this angle is the same as this angle because these are two parallel lines. So this angle is also sine inverse 7 upon 25. So you have the angle theta is equal to sine inverse 7 upon 5. Theta, you can find it. You have the hypotenuse, you can find the height. So we can equate loss of potential energy, gravitational potential energy, gaining kinetic energy, and work against friction. Now, what is loss in gravitational potential energy? It is mgh. What is mgh? It is the mass, acceleration due to gravity. You are given the mass, acceleration due to gravity is 10, and the height here, it is hypotenuse times sine of sine this and inverse, this cancel. So you will have 0.45 times 7 upon 25. You multiply all this, you will get the loss in potential energy. The loss in potential energy will be equal to the gain in kinetic energy here plus the work done against friction. Okay. Now, what is kinetic energy here? It is half mv square. You are told that during this distance to travel, its speed is 0.6 meter per second. So you have to replace it. You will get gain in kinetic energy. Now, what is work done against friction? Work done against friction is force times distance. Frictional force times this distance. And we have to find frictional force. Because only when finding the frictional force that we can find mu. So let us equate this. Loss in potential energy is equal to gain in kinetic energy plus work done against friction. You just replace it, you will get frictional force. Now, frictional force equal to mu r. What is frictional force? You know now, it is 0.24. What is r? Now, look at here. When the mass is here, the body, the bead is here, there is a reaction force moving upward. So there is a downward force. and this is the mg, 0.1 g. Now this angle is the same as this angle. This is also sine inverse 7 upon 25. Now you have theta, sine theta is 7 upon 25. So Pythagoras theorem, you will know that this is 24. Now what about theta? Theta is sine inverse 7 upon 25. So sine theta is equal to 7 upon 25. Theta is equal to 16.26. So you will get this, the component here. Okay, so it is cos 0.mg cos theta, and mg is 0.1 g times cos 16.26. So you replace all by this, and mu here, then you will get mu is equal to 0.25. Very interesting question. Now, let us see this part. There is another bead B of mass 0.5 is also threaded on the wire at the point when A has reached 0.5. Therefore, at this point, when it has reached 0.45 meter, it hits B. It hits B and becomes instantaneously at rest. Then B will move. Now we have the weight, the mass 0.1 kilogram, this mass 0.5. Both will, this will move down and this also will move down. A time will reach when they will meet again. Therefore, B is moving slowly and A is moving rapidly so that it can move. It can meet B. Now, what is the question? The time when they meet again. After collision, when they meet again. The time from when collision occurs until A collides B again. A meets B again. So the time. So what to do? Let us find the velocity B is moving after collision. So we take momentum before is equal to momentum after. Now you know that B was stationary, so we can cancel this. After collision, A remains stationary, momentarily instantaneously at rest. So you can cancel this, you can cancel this. So you remain with all these. So you replace MA, you replace UA, the speed it is moving. Then MB, then the speed of B is 0.12 meter per second. Now to find displacement of A and B after time t, we should first find acceleration of A and B. If you want to find displacement, so you have to use the formula s equal to ut plus half at square. Now you have to find acceleration of both, okay, to find displacement. Because only in this formula that we are going to have t. Get the point? You're told to find the time. So you have to use s equal to ut plus half at square, but in this formula, you have to find the displacement as well as you have to find the time. Now, to be able to use this formula, you have to find acceleration of both. Okay, let us find the acceleration of both. Now, for acceleration of A, resultant force equal to ma. Now, what is resultant force of A? What is resultant force of A? A. Now, resultant force of A is very simple. It is a resultant force of A is A is moving with gravity. Why B is moving? B is moving because A has transfer energy in it. But A is what after A is move, B is moving. A is also moving, but A is moving because of gravity, the component of weight, which is moving in that direction, minus frictional force. So you have the mg sine theta, component of weight that is causing it to move down, minus frictional force. Now you already have in the first part mu. So mu r. Now you know that 0.1 times 10 times cos theta. Okay, this is r. This is mu, this is r. You find it in the first part of the question. This is friction. So component of weight minus frictional force. You replace all these values, you will get 0.4. Now remember that sine theta, you were given sine inverse theta is equal to 7 upon 25. You see, sine theta is sine, this is sine, theta is sine inverse 7 upon 25. I have omitted all these. Okay, now this is the 0.25 is mu, or 0.1 times 10 cos theta. Cos theta is cos theta is theta. You know that it is theta is in this first part 16 times 26. So cos theta is 24 upon 25. So you just replace it here. You will get is equal to ME. Don't forget ME, mass of particle A. So you will get this acceleration. Now acceleration of B now. Same thing. B is moving down. So mg sine theta. Now don't forget that mass of B is 0.5 minus. Now you are told that the mu for B is 0.275. The mu for B, not the same, 0.275 m cos theta, mg cos theta. Okay, this minus frictional force, you will get acceleration. Now you can see that the acceleration of A is more than acceleration of B. This is why A will meet B, because the acceleration of A is more than acceleration of B. So displacement of the A after time t, we use this formula, displacement of A after time t, because after time t, this and this is the time taken t. After time t, the displacement of A will be the same as the displacement of B, because they meet at this point. So after the displacement of A at time t, you just A was instantaneously at rest. You remember when B collided with A, it was instantaneously at rest. So U is equal to 0. Half A, you know, now we know 0.4 t square. You get a relationship here. Now for displacement B, 0.1 to t ut, because it is moving with this speed. How you get this? From the momentum here. Okay, ut plus half at square. Now you know the acceleration from here. Now you have the displacement of A. Displacement of A. You have the displacement of B. You have to equate both displacement, and you have t once again. Why? Because the displacement of A after collision is the same as displacement of B after collision, because at time t, they should have same displacement so that they can meet again. This is why we have to equate both displacement of A and displacement of B. Okay, this is how we have fun with maths. Okay, bye-bye.